We'll be looking into a new topic, STURM LIOUVILLE problem. STURM LIOUVILLE problem. When we talk about a STURM LIOUVILLE problem, a second order STURM LIOUVILLE problem is a homogeneous boundary value problem of the form P of S y prime prime plus Q of S y plus lambda W of x y is equal to 0. So when we talk about where the boundary conditions can be written in the form of lambda 1 y of a plus beta 1 y prime of a is equal to 0, lambda 2 y of b plus beta 2 y prime of b is equal to 0, where p of s, p prime of s, q of s and w of s are continuous on a comma b and both p of s and w of s are positive on a comma b. This P of S, whenever we heard about a STURM LIOUVILLE problem, just like it must be in form of a second order and it must be in the form of a general form, which is this. Another form of writing this, in some textbook, you might find as P of X d all over dx, P of X d all over dx plus Q of xy plus lambda W of x y is equal to 0. The reason why is homogeneous because remember when we talk about homogeneous is if g of s is equal to 0, that is if all this is equal to 0 is an homogeneous. But if g of s is not equal to 0, it is non-homogeneous. That is why a STURM order, second order, and the reason why it's a second order is what? It's a second derivative. That is a derivative that is a second order that is having a what? Derivative like d square all over dx y. If I have something like this, it's a second order. If I have dy all over dx, it's a first order. If I have this cube y all over what? Dx cube is a third order. So a second order it must be in second order. And if you have any form in form of this, it's a STURM LIOUVILLE problem. And if it's not a form of this, it is not a STURM LIOUVILLE problem. So this is how to know when a second order is said to be what? STURM LIOUVILLE statement or problem or general form. And this boundary condition, we use this boundary condition if you have to solve anything related to second order ODE, that is a second order ODE, which is homogeneous, that is equal to 0. We are going to find alpha y of a plus beta y prime of a is equal to 0, and all these must also be equal to 0. Where p of x, p prime of x, q of x, and w of x are continuous on a comma b, that is a is less than or equal to s is less than or equal to b. A function, when we talk about a continuous function, a function is said to be continuous if it is well defined. Yes, if it is well defined, it's a continuous function. If its limit exists, it's a continuous function. The reason we have this is a is less than s is less than b is a continuous. This is a what? Is a closed interval. It's a closed interval, that is, it is from a and b. And whenever we talk about a continuous function, that is, we are talking about a closed interval, something like a form of this. It means if we want to draw a graph of a and b here, it will be easy for us to draw. Why? Because the graph moves smoothly without what? Without going to another places. If I have x, this is y axis, and this is what? S axis. This is s axis. So it means if on my x here, a, that is, if this one is 0, that is, if s is equal to a, it means if our s is equal to a here, then my b is b here, it will be a and b. So that is, it is from a to b. You can say that from a to b, there's no little difference. But if I said if it is from a to e, you can say that before a to e, there's a what? B, C, D. It's not a smoothly. So 0, 1 is a what? 0, 1 is also a what? Is a continuous function. Why? Because it goes smoothly while drawing the graph. That is from 0 to 1. That is 0, 0 0.2, 0 0.1. So that's what we call a continuous function. That is, our s is equal to a, our s is equal to b. You can see that's why we have a and b. And p of x here must also be continuous on A, and P prime of S must also be continuous on B, and Q of S must be continuous, and P of S and W of S must be what? Positive. And if it is positive, it means it satisfies a second order STURM LIOUVILLE problem. This So when you have a second order in form of this, it means what? Is a what? Is a what? Is a second order STURM LIOUVILLE problem. So let us consider this STURM P of x y prime. Let us what? Let us differentiate this. So we want to open this bracket. What are we going to have here? This is a what? This is a what? A product function. P of x and what? P of x, y prime and prime. So let us take P of x. P of x, y prime. If you differentiate again, it's a product. This is V, this is V. If you differentiate again, we're going to have prime. That is P of x, differentiate again, we're going to have prime. So here we're going to have prime. That is P of x, y prime prime plus, you know it's a product rule. We are going to take what? Y prime. And if you take this one, what do you have? This is what? D all by dx. Differentiate P of x, y prime again. What are we going to have? If you differentiate this of the x way, we are going to have y prime as well. So therefore, we are going to have P of x, y prime prime plus what? P of x, y prime. So you can see. So that's how we get P of x, y prime prime, P of x, y prime. Then here we can write it like plus Q of x, y plus lambda w of x, y is equal to 0. So it can be in form of this. It's also a what? It's also a second order STURM LIOUVILLE problem. It can be in form of this. It can be in form of this. It can be of either way, but it must be what? It must be in form of this. You can see that when I open this, I got this, and it can be a form of this as well. Since y prime is what? First derivative, dy over dx, another derivative, d over dx. So that's how to what? That's how to know when our what? When our second order is set to be what? Homogeneous. Let us check next video to consider some example of what? Homogeneous. If this is homogeneous or if it's not homogeneous.